Hello again, kids. This is part two of the Tuesday mini lesson. It won't take this long to do the mini lessons in the future. The reason I think is because we're still getting used to using Kami, and I have to explain how you get to Kami and open up Kami assignments and find them in Schoology and how to turn them in and all that stuff. And that just causes us to take a little bit extra time that's not really focused on teaching the math lesson. And so in the future, I'm pretty sure we're not going to have two videos for the math lessons. It'll just be one. So I'd like to remind you we're in the lesson 9 problem set. In the first video, we covered problems 1 and 2. We started to look at number 3, and number 3 we noticed it takes a different approach than number 2 did, where we distributed a 5 times 2 and a 2 times 2 out of the 7 here and just put them back together again at the end. This one actually shows us that 9 times 2 has a close related fact, which is 10 times 2, because 9 groups of 2 is really close to 10 groups of 2. But 10 is a friendlier number than 9. You can quickly put together two 10s to get 20. So if you're skip counting or doing a count by, 10, 20 gives you two groups of 10. And now we take away this last group here of 2. 1 times 2, 1 times anything is that number that you're multiplying by 1 is 2. And down in the box here, 20 minus, so here's the 20, here's what we're taking away. 20 minus 2 gives us 18. And then, so 9 times 2 is going to be the same as 10 times 2 minus one group of 2. Okay, so we're looking at this number right here, 18. And we can confirm it with a count by. So we'll count by twos. Count with me if you can. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so 9 times 2 gives us 18. So you see how I'm just keeping the feature on the text box here, and so whenever I click on the document, it gives me a text box anywhere I want. So I can fill in all these blanks very quickly and easily once I understand what's going on. Okay, so now moving on to the story problems, the word problems. I'll just remind you, we do problems like this almost every day in our application problem work. So the strategies and approaches and processes that we're talking about in those daily daily lessons uh, with the problem sets, or I'm sorry, not the problem sets, the application problems. You'll use those with these problems as well. So we almost always use the read, draw, write process, and our approach always includes visualization. So we visualize ourselves or someone that we know in the situation so that we can make it real in our minds and give us a better idea of how to put it onto paper. Okay. So I'm going to read the problem. You can use the text-to-speech feature here if you have trouble with the words on your own. You click it and you stop it, okay? So you have to click it to start it and click it to stop it. Matthew organizes his baseball cards in 4 rows of 3. Okay, this is code language right here for arrays. I don't really care who I don't really care who Matthew is. I'll pretend that it's me or someone else. Now, I know what baseball cards are. You may or may not know what baseball cards are. I did collect baseball cards as a kid. I have probably thousands and thousands of them. But anyway, that's a side point. The the idea is we've got 4 rows of 3 items. And then right off the bat, they tell us to draw an array that represents Matthew's cards using an X to show each card. Okay, so they're actually telling you what your picture should look like right here. So I don't know if you remember the lesson from yesterday, but there are several ways that you could do arrays. You could use a drawing like this, pick your color. I don't really care what color you use. You could draw X's like this. 4 rows of 3 means I have to do 1 row of 3 like this, and then I drop down and start the second row of 3. Another way to do that, so I'm going to erase, just drop the plus on the X here, but you'll notice that it goes line by line with that. Another way to do it here would be to select shapes and look for an X shape. I don't really see an X shape here. I do see a line. So if I wanted to draw a line like this, I could, and it gives me those fancy degree marks on there. That's another way I could do it. But I know that X is a letter of the alphabet, and if I use a text box, I can get perfectly clean lines using a text box. So that's the way I'm going to do it. That's the way I like to do it. Um, I'm going to use a text box here. So I'm going to drop a text box in. I'm going to expand it out a little bit. And I'm going to use, I'm going to go a little bit bigger here. I'm going to go to 24. Nope, that's a little too big. I'll go to 18 point, which is the font size. And I'll do X space X space X. Okay, and then I'll hit the enter button. X space X space X. Look at those neat, clean rows. So there's 2 rows of 4. X space X space X, and then another one, X space X space X. Okay, and then I'll close this up here a little bit to show. Did I do what they asked me to do? I just need to check in, draw an array that represents Matthew's cards using an X to show each card. 4 rows of 3. Okay, 1 row of 3, 2, 3, 4. So I'm modeling my thinking, I'm modeling my check, I self-check. So like I just want to make sure I did the right thing. And it's a good idea for you to check too, to make sure that you did the right thing instead of just buzzing through and moving on. And I know I was 8 once too, and math wasn't my favorite thing in the world then. It's one of my favorite things in the world now. But when I was 8, I would be buzzing through this trying to get to the next thing. Well, what I didn't realize when I was 8 was that caused me to make mistakes that I wouldn't have otherwise made if I just did a simple check on what I was supposed to do. So go back and check your work every time. Make sure you did what they asked you to do. Okay, so now they say solve the equation to find Matthew's total number of cards. They give you 4 by 3. They give you a space here that they don't really tell you what to do with it. If you wanted to do a count by, you could do a count by. You could just like number the side here. You could go back into your text box, stretch it out a little bit, and here you could put okay, here's 3. So you could do your count by. I'm going to give it a little more space. 3. Now down a little bit. 3 more makes 6. 3 more makes 9. And then 3 more makes 12. Okay, I'm counting by threes. 3, 6, 9, 12. So a count by is a good strategy. If you needed to count every single one, you could. If you wanted to put the first 2 rows together, 2 times 3, that would be actually a good thing to do to show. So to show the strategy that you can combine 2 smaller problems to make a bigger problem, you could do this. One group is 2 times 3, and so that would represent these 2. And then another group, you have to add the other group of 2 times 3, because the bottom part, we can't just leave that out. And each of these groups of 2 times 3 is the same thing as 6. So 6 and 6 equals 12. You could do it that way. You don't have to do that. Any way that you come up with 12 is fine with me. Like I said earlier on, math, one of the beautiful parts about math is people think about how to solve the problems differently. This would kind of reflect what they were showing us earlier on, that you could take a bigger problem, 5 times 5, and break it into 2 smaller problems, 2 times 5 and 3 times 5. All right, I'm not going to do too much of this extra work. I'm ready to turn you loose. You've been listening to me long enough. I haven't given you a whole lot of time to actually do any work, but I would like for you to try your best to solve these last 3 problems And I've done all the problems for you except for number 2 here, and number 5, A, B, and C. So you're feel free to copy my work on the problems that we've already done, and practice submitting. So this is my version here. I don't have the turn in button, but it's right up here. When you're done, turn it in to me. I will see your finished work and give you credit for participating in today's math lesson. Good luck, do your best, and I will see you soon.